So it's going to come like this back to right here. We're at Port Canaveral. Those showers are offshore over here. So we're getting some storms that are building, and those are some pretty big ones. Those are offshore. So you can see a couple of them out there. So the clouds here have kind of that look that it's going to produce more of this. It's going to produce more snow. Some of these storms, as they go vertical, are getting blown off when you get up to 15 to 20,000 feet. You never know it's even in the water, but you can see some of the larger objects, including a truck right here.
On the east side of the city is where the cone of uncertainty is, and that's what we see right here. Here is Houston. This is where I'm standing right now, and just on the edge. There's a lot to learn between here and whether or not Houston eventually will end up being in the cone.
But first, I want to show you something else, a reason why it could have been much worse. I'm going to go pop out real quick and show you here. We're parked, but look at this. Look at this field right here.
And it doesn't need to be raining where you are. A street like this in a valley can funnel the water, creating a dangerous setup for a flash flood.
This water is about 6 inches now, and it's enough to stall vehicles and even float vehicles in some cases. You're going to lose control, and you don't want to be this guy. You never know it's even in the water, but you can see some of the larger objects, including a truck right here. Absolutely life-threatening situation.
And the reason wind is bad, it does a couple of things. It helps bring more oxygen into the fire, which can fuel the fire. But what else can happen? You can get these little embers that will come up, and those embers can get pushed and deposited somewhere else, and that can start a new fire.
The smaller clouds essentially showing us where the winds are at the surface, going like this, and then up between about 15 and 20,000 feet higher up with the upper level low, we see how some of these storms, as they go vertical, are getting blown off when you get up to 15 to 20,000 feet, and you're seeing that like this, and it's these storms right in here that are explosive, are rotating, and are producing these large wedge, long-lasting tornadoes.
Waterlogged right there when you're seeing these puddles where there's normally grass. Let's hop on the road and let's take a look at the sky as we head back a little bit closer now to Orlando. We're just south of Orlando. I want to show you the horizon, and there are still some showers that are firing up, and you can see the clouds that are building. And when you look at these clouds, you see the blue sky overhead, and look where the blue sky comes down and touches the cauliflower type look of the clouds. When it has that crisp look, that cauliflower look to it, that tells you these clouds are still building.
I'd imagine all of these wires right here are different layers in the atmosphere, with the ground being the surface. At the surface, there's been winds out of the south-southeast. You go up several thousand feet, south-southwest, so the winds are turning in direction. But it's been what we call elevated convection. So again, the air starts rising up here. It's missing out on this lower level of wind turn with height. So that's a big reason why we've seen showers and thunderstorms, but the showers and thunderstorms, the thunderstorms themselves, have not been rotating.
And we're looking at about 23 miles, okay, from here all the way up here. So you're getting 4,000 feet difference from here to here. And there's a reason there are switchbacks going all the way up, because you are gaining a lot of elevation, and without chains, we know, Justin, going up some of these steep slopes is just not going to happen.
Leaving behind a muddy mess of debris and dangers like sharp objects, hazardous waste, also a big concern, and down power lines. So follow the forecast, and remember, when a road is flooded, always, always turn around. Don't drown.